Morning, everybody. Myself, Sankar Karmaker, uh, Assistant Professor, Department of IT, Kolkata Institute of Technology. Today, I am going to discuss about the first unit of compiler design. Topic to be covered: translator, analysis, synthesis, model of compiler, phases of compiler. Uh, so, just this topic will be today I discuss. First, before that, we have to know the translator. What is translator? Translator is a program that takes one form of program as input and convert it into another form. So this is the source program, which is written on program that is as a take as an input, and it will be converted into the target program, which is written as the another languages. And if there is any error, message, so you will get the message, and after recover the error, again you have to get the source program and translate this into the target. So this is the translator. So next, the translator are three type. One is the compiler, interpreter, and assembler. So three type of translator. When we are write anything in by keyboard, that will be written as the high level language or text, English languages, and that will be converted into the another languages human acceptable form. So before this, write is a program and convert it into the another language. So in that case, we have to need the translator, and there are three type of translator. First one is the compiler, second one is the interpreter, and assembler. So compiler mean what is the definition of compiler? A compiler is a program that reads a program written in source language and translate it into another equivalent program in the target language. So one example is given here is suppose a small code of C language is given, which is written as the high level languages like void main int a is equal to b is equal to 2 and c. And we are finding that c is equal to a plus b and printf c. We will write that is the source program, which is written in the one type of languages. And if we use the translator as a compiler, that will be that compiler will translate this code into the another target program. That is, and if there is get any error message, you maybe get the error message if you have any mistake in your you do mistake any type of mistake in your code source program, then that will be get as a error message, and after recovery the message error, then you run again and compiler will be translated into the target program. So this is the compiler. Next, interpreter. Interpreter is also a same as a translator. The interpreter is also a program that reads a program written in source language and translate it into another equivalent program in target language, and the program will be executed in line by line. So this is the difference between the compiler and interpreter. This compiler that compile the all the program after executing all the line of the code will be executed, then it will be compile and get the target program. But in the interpreter, the difference is that the program in the source program or the line source program, the code will be executed in line by line, and you will interpret and you will get the target program. So this is the difference. The line by line executed, and you will get the corresponding target. So next is the assembler. This assembler is what? This definition of assembler is it is also one kind of translator. It is a translator which takes the assembly code. So in before that, the interpreter and compiler we just write the source program is a some languages like C program is written here. But in assembler, it is the quite different from the two others translator. Like here, the code is written as the assembly code, and in assembler that will be converted into the machine level language or machine code. So this is the assembler, and this if you there generate any error, you just handle that error, and after that you run again and you'll get the machine code. So these are the three translator. Next topic is the analysis, synthesis, model of compiler. So in mainly we are discuss about the compiler. So in compiler there are two phases. One is the analysis phase, another one is the synthesis phase. So analysis phase mean what? This is that the program, the source code will be written and that will be analyzed by the analysis phase. After analyzing, it will be generate some intermediate representation, and this intermediate representation will again go to the synthesis phase, and that synthesis phase perform some operation and it will generate the target code. So these are the two phases of the compiler. One is the analysis phase and synthesis phase. And there is a basic difference between the analysis phase and synthesis phase is there, that the analysis part breaks up the source program into constituent pieces uh, and creates an intermediate representation of the source program. That means the all of the line will be pieces in a small size, and in the synthesis phase, or the synthesis part construct the desired target program from the intermediate representation. Next, in the analysis phase difference, another is analysis phase consists of three sub phases: lexical analysis, syntax analysis, and semantic analysis. And synthesis phase are consist of sub phases. One is the code optimization and code generation. So this is the basic phase of the compiler design. That the in compiler, that is the analysis phase. In analysis phase are three part, that means the lexical analysis, syntax analysis, and semantics analysis. And after analyzing this three part, they generate the intermediate code, and this intermediate code go to the synthesis phase, and synthesis phase again synthesis the code optimization and code generation. Then we will get the target program. Next, syntax analysis. Now discuss about the analysis phase. First, we have to discuss the lexical analysis. In the lexical analysis is also called the linear analysis or scanning. So linear analysis or scanning. Lexical analyzer divides the given source statement into the token. Suppose in an example, position is equal to initial plus rate into 60. This is one kind of mathematical expression would be grouped into some following token. If we see this expression as a arithmetic expression, or that can be generated in some token. Suppose position. This position is a one kind of identifier. And next, this equal symbol is that the assignment symbol. This initial is, this is one kind of another identifier. Then this plus, this is the plus symbol, that is the operator. Next is the rate. This rate is the another identifier, and then multiplication symbol, and 60 is the number. So this is actually defined by the lexical analysis that analyze the any kind of mathematical expression, and that will be generated like that. The position is equal to initial plus rate into 60. This is the actual expression of the mathematical expression. After analyze the lexical phase by this expression, that the expression will be analyzed by the lexical analysis phase, and as the all of the token will be generated like identifier 1, identifier 2, identifier 3, and into 60 with the operator. So this is analyzed by the lexical analysis. So next part is the syntax analysis. So syntax analysis, after getting this analysis phase, it goes to the syntax analysis, and it is also called parsing or the hierarchical analysis. So the syntax analysis checks each line of the code and marks every teeny mistake. If there is any kind of teeny mistake, then that will be analyzed by the syntax analysis. If code is error free, then syntax analysis generate the tree. So the expression is just right as the position is equal to initial plus rate into 60. This is the mathematical expression or arithmetic expression. After analyzed by the lexical phase, we just get that the identifier 1 is equal to identifier 2 plus identifier 3 into 60. Now this part will be analyzed by the syntax analysis. So after getting this on, the syntax analysis is defined like that, that make a tree, which is called the parts tree, that is the identifier 1 is equal to, then plus symbol, it will another branch is identifier 2. This goes to the multiplication identifier 3 and 60, that is the two hand of the multiplication. So that the expression, that token which generated by for the mathematical expression which makes a tree like this one. And next part is the semantic analysis. So semantic analysis determine the meaning of a source string. So it performs following operations. Actually, this semantic analysis perform the matching on parenthesis in the expression. If suppose there are given expression which is having the parenthesis, so it is checked whether the open and close parenthesis is there or balancing the parenthesis. That will be checked by the semantic analysis. Matching of if else statement. Suppose there are some condition if and else, so that will be also checking if that will be balanced. If somewhere if or somewhere else is missing or not, that will be also defined by the semantic analysis. And performing arithmetic operations that are type compatible. And next is the check the scope of operation. So this is the initial given the expression, that is position is equal to initial plus rate into 60. And that will be generated with some identifier as a, and get will the we get just the parsing tree which is defined by the syntax analysis. After that, this part will be defined by the semantic analysis, and that will get that the identifier equal that plus identifier 2, that will be another two branch start, that is multiplication symbol, and this will be having two hand, that is identifier 3, and real into real, and this number is 60, that will be into real and to get the 60. So this is the semantic analysis we defined. After that, intermediate code will be generated. So in intermediate code, after getting this the parts tree by the semantic analysis, that parts tree will be that will be designed, that will be get by the semantic analysis, that on kind of tree, and this will be generate the intermediate code generator. The intermediate code generator is what the intermediate code generator. The intermediate code generator, there are two important properties. One is it should be easy to produce, and second is easy to translate into target program. Next point is intermediate from can be represented using three address code, and three address code consists of a sequence of instruction, each of which has at most three operand. So to the end, this is the last we'll get by the semantic analysis. So that will be generate the intermediate code. Suppose this is the window, some window will be just given here as shown. This is the last part, that is the into real is 60. We just take this is T1, and it has the two hand under the multiplication, that is the identifier 3, and this window will take as a another variable, that is T2, and this window will be take in under of the this plus operator, that is the identifier 2, and this part that is take T3, and this T3 will be just take as the right hand of the equal symbol and identifier 1. So after getting this window, intermediate code will be generate this the T1 is equal to into real, that is 60, T2 is equal to that is the identifier 3 into T1, and T3 is equal to T2 plus that ID 2. That is that you just say that is this is the T1, that is T1 is the into real which is 60, and this T2 is equal to what? T2 is equal to that ID 3 and this value, that is T2, and T3 is equal to what? That is this T2. T2 is T3 is equal to this ID 2 and this hand, that is the T2. Now we will get the, and ID 1 is equal to that T3. This is the T3 is the ID. We will get the, we just write this type of equation, and we will define in the code optimization. Now this part will be go to the in the past we have seen that there are two phases is there, that is the one is the analysis phase and synthesis phase. So this after the intermediate code generation, this part will be goes to the synthesis analysis part, and they will be generate I mean there will be evaluation of this intermediate code. That the code optimization is fast for the synthesis phase. It improved the intermediate code, This is necessary to have a faster execution of code or less consumption of memory. So intermediate code, that will be that it will be minimization of that the code will be written here. That is T1 is equal to into real 60, T2 is equal to ID2 into T1, T3 is equal to T2 plus ID2, and ID1 is equal to T3. So that can be minimized and requirement the that the code optimization here we can optimize this code, because if we optimize this code, then the number of memory space will be required less, and execution time will be automatically decreases. If you not optimize, then optimization is the big challenge nowadays. So optimization will be there. So that code optimization will be required. There are the 1, 2, 3, 4 line of code is there. If we optimize this one, we will get only the 2 line. That is the T1 is equal to ID3 into 60 and ID1 is equal to ID2 plus T1. After optimization of this code, we will get this part. So this is the code optimization. Next part is the code generation. So code generation, that is the intermediate code instruction are translate into sequence of machine instruction. That is the code optimization. After code optimization, we'll get this one, and then this code will be written as the three addressing instruction. That is the code of generation that will be generated. That generated this code generation will be write as the three addressing code in the above equation. So we'll get that move ID3 R2. That is R2 is this ID3 will be moved to the this address register, and then MUL mean multiplication 60 into R2. That initially that ID3 goes to the register R2 and ID2 will go to the register R1, and move ID2 with R1 and add R2 R1. After addition of these two value R2 plus R1, that will be stored, the result will be stored in R2, and move ID1 to R1. That means the values will be goes to the memory. So these are the total page of the compiler design, and the pages are there, and there is some given assignment. This assignment can be solved in this all the pages that write the output of the all pages of compiler. So you can also solve this way in the above given example. X is equal to b minus c into 2, and a is equal to a plus b into c into 2. You can solve it. This is the total compiler design, and the pages are defined here. So thank you.